Welcome back everyone, and I just want to do a quick video also on the u-substitution method, but it'll just be a quick 2-minute video explaining how to take the integral of secant x dx. So this, I had mentioned in my last video that you can't, there's no inner outer function concept, and you have to, see a different way, but same general steps we can follow. Define a function, find dx in terms of u and du, and integrate and replace. So same general steps, but in this case your u will be something different. So you can start out this this integral, and you can multiply instead of, even because you can't really replace anything, you should multiply the secant x top and bottom by secant x minus tangent x. So it's the same thing. This is the same thing. It equals that. But the reason I'm doing this will become clear in a second. I'm sorry, I forgot the dx. And the reason I'm doing this will become clear in a second, because when you multiply this out on the top, it'll become secant squared x minus secant x tangent x over tangent x. So when you're looking at this bottom thing, and you can see that if you take the derivative of this, it'll actually be that, because the derivative of secant x is secant x tangent x, and the derivative of tangent x will be secant squared x. So what you want to do now, once you see this great relationship between two separate parts of the problem, you want to take the simpler one, you want to take the one here and replace it with u. So it'll be secant x minus tangent x, and like I said, now you want to find, I forgot that again. Now you want to find the dx in terms of u and du. And yeah, don't forget this dx, because this is very important, because it comes back and you have to replace the dx in terms of u and du, and that's a very big part of these substitution problems. So du is equal to secant tangent x minus secant squared x dx, and then dx is equal to du over secant x tangent x minus secant squared x. And so now again we replace these things back into here, and we get the integral of secant squared x minus secant x tangent x over u times du over secant x tangent x minus secant squared x. And so now you can pretty much cancel these out, with the exception of having a negative sign, because you can see that if you multiply one of these by a negative, you'll get the same thing. So just keep in mind, I'm just going to put a negative there to remind myself that there's going to be a negative here. And so what you have left, and again it's very important to cancel all these x's out, because you have to have to integrate something, it has to all be in one variable. At this point we can't do multi-variable integrals, so we have here negative 1 over u du, and the 1 over u is actually just the natural log derivative. So since we know that, we can just say negative natural log c of u plus c. And now we can replace the u with secant x minus tangent x and add that into our answer. So there you have it, that's our final answer.